Good morning, Professor. My name is Liu Yiwei. My metric number is BB23110517. First of all, I'll show the question of our group assignment. Now I will present part 1, which is construct appropriate graphs or charts to compare the relative frequency and cumulative relative frequency between the two metrics. Relative frequency can be defined as the number of times an event occurs divided by the total number of events occurring in a given scenario. First of all, we need to build an ascending order table and a frequency table that consists of frequency of number of visits and number of purchase order in e-commerce website. After that, find the midpoint by dividing the sum of two values, such as divide sum of 19 and 10 by 2 and get the midpoint 14.5. To find the relative frequency, divided the frequency by the total number of data values. This is my relative frequency of number of visits and number of purchase order in e-commerce website graph. The red line shows the number of visits in million and the purple line shows the number of purchase order in million. In my analysis comparing the relative frequency between number of visits and number of purchase order, I observed that number of visits had a lower relative frequency comparing with the number of purchase in class 1 and class 2. For example, the relative frequency of number of visits in class 1, which is 0, which is lower than the number of purchase order, which is 0.1667. However, number of visits had higher relative frequency comparing with the number of purchase order in class 3, 4, and 5. For example, in class 3, the relative frequency of number of visits is 0.4333, which is higher than the number of purchase order, which is 0.3. After that, the cumulative relative frequency is the sum of all relative frequency. So we can get this by adding this number with this, and we get this number. This is my graph about the cumulative relative frequency of number of visits and number of purchase order in e-commerce website. The blue line shows the number of visits in million, while the red line shows the number of purchase order in million. In my analysis, comparing the cumulative relative frequency between number of visits and number of purchase order, I observed that number of purchase order consistently had higher cumulative relative frequencies for all the class across all data points. For example, the cumulative relative frequency of number of visits in class 1 is 0, which is lower than number of purchase order, which is 0.1667. Both metrics converge at a cumulative relative frequency of 1.00, indicating that both metrics cover the entire dataset. If there is a possible relationship between the relative frequency and cumulative relative frequency for the number of visits and purchase orders, it suggests that as the number of visits increases, the cumulative of purchase orders also increases. This implies that a higher proportion of visits is associated with a higher cumulative of purchase orders. That's all from me. Thank you.
Hello, Doctor. Good evening. Today, I'm going to present about the group assignment of data analysis and business intelligence. My part is part 2, calculate and compare measures of center location between the two metrics. My name is Cheong King Xiong, and my matrix number is BB23161072. In my group assignment, there have 30 types of e-commerce website, number of visits in million, and number of purchase order in million. We need to find 3 types of center location, which is mean, mode, and median. So what is mean? Mean is the average of the given numbers and is calculated by dividing the sum of given numbers by the total number of numbers. So after we calculated the mean with the formula of mean in the number of visits in million and the number of purchase order in million, we found that in the number of visits in million, the mean is 37.71,333,333. While in the number of purchase order in million, the mean is 166.81666667. so which is larger than the number of visits in million. So the second one is mod. What is mod? Mod is the most frequently occurring value in a data set. So as you can see, in the number of visits in million, they have 234.1 occurring at the same time. So the mod is 34.1. So how about the number of purchase order in million? They didn't have the two types of same value occurring at the same time. So the mod is NA, which is nothing. So how about the median? The median is when the data are arranged in the ascending order. The median is the middle value if the number of observation is odd, or the average of the two middle values if the number of observation is even. So after we calculated the median with the formula of median, which is calculated by add the 15 value and the 16 value and divided by 2, we found that the median is in the number of visits in million is 34.5. Wow. In the number of purchase order in million is 163.9, which is larger than the number in visit in million, which is 34.5. So that is all from me. Thank you.
Hi, good morning everyone. My name is Ching Sin Mei and my metric number is BB23110553. Today I'll be presenting part 3, which is calculate percentiles and construct box plot for each matrix. The data contain of number of visit and purchase for the 30 e-commerce website. From here, we can see that Q1, Q2, Q3 and minimum maximum value for the number of purchase are higher than those for the number of visits. From my opinion, this indicates that within the observed sample, the e-commerce website are more efficient in converting a portion of their visitors into customers, such as websites with higher Q1, Q2, and Q3 for purchase orders may have implemented successful marketing strategies that not only attract visitors but also encourage them to make purchases. This could include persuasive product description, special promotion, or a seamless user experience. Let's move to interpretation based on the box plot for the number of visits and number of purchase orders. As we can see that median line inside the box for the number of purchase orders is higher than the number of visits. Some websites are more effective in converting their visitors into customers. Moreover, both box plot for the number of visits and number of purchase orders, their right whisker maximum point is longer than their left whisker, and the median is closer to the left side of the box. And the data is skewed to the right, indicating that there are few e-commerce websites with exceptional high numbers of visits and purchase orders. This suggests a positively skewed distribution. Other than that, box plot for the number of purchase is larger than the box plot for the number of visit. It indicates a greater variability or a spread in the data for purchase orders compared to the data for website visit. A larger box plot for the purchase orders suggests that there is more diversity in the performance of e-commerce website when it comes to converting visitors into customers. Some websites may have significantly higher purchase orders numbers, while others may have lower conversion rates. If the purchase orders box consistently surpasses the visit box, websites are not only attracting traffic, but also successfully in converting a significant portion of it into purchase orders. That's all from me. Thank you.
Good morning. Good morning for the Dr. everyone. My name is Pang Wei Ren. My metric number is BB23110626. Today I want to present my part 4. My part is calculate and compare measures of division between the two metrics. In this data we can see we have the number of visits and the number of purchase order for the e-commerce website. The standard deviation for the number of visits in million is 8.7239. 0.679. Well, the standard deviation for the number of purchase order is 31.42601693. Then the sample variance for the number of visits is 76.10257. Well, the sample variance for the number of purchase order is 987.594542. The kurtosis for number of visits is negative 0.80514. Then the kurtosis for number of purchase order is negative 0.846862476. Then the skewness for the number of visits is 0.271892. Then the skewness for number of purchase order is 0.18502248664. And the last, the range for number of visits is 31.2, and the range for number of purchase order is 115.4. Thank you. That's all from me.
Good morning, Professor. My name is Liu Yiwei. My metric number is BB23110517. Today, I want to present part 5 in our group assignment, which is calculate and interpret measures of association between the two metrics. First of all, this is the table for the raw data in million. There are 30 e-commerce websites in the table, example Lazada, Shopee, and so on. Here are the number of visits in commerce website in million, and this is the number of purchase orders in million. After that, we need to build an ascending order table for the number of visits in million and number of purchase order in million. Then, we need to build a table for measures of association. What is measures of association? Measures of association are statistical techniques used to quantify the relationship between two variables. The first thing we need to do is to find the covariance. The covariance describes the direction of the linear relationship between two variables. First, search the formula for covariance, and this number get from the number of visits in million in the ascending order table. After that, this number get from number of purchase order in the ascending order table. Then we can get the number of covariance. What is correlation? Correlation describes both the direction and the strength of the relationship between two variables. Before we find the number of correlation, we need to find the standard deviation of the both metric first. This is the standard deviation of number of visits in million, and this is the standard deviation for the number of purchase order in million. This number get from here, and this number get from here. We can get the number of correlation by divide the covariance by the multiply of standard deviation of both metrics. This multiplied by this. This divided by the two. A correlation of 0.98049 suggests a strong positive relationship. As number of visits increases, number of purchase order is likely to increases. That's all from me. Thank you.